Hello students and welcome to this video. In this video we will solve question number 351 to 360 of permutations and combinations. So if you have not watched earlier videos, make sure that you watch earlier videos in the playlist, particularly the theory ones as well as problems. The link to download the description will be in PDF, and at the end I will show you how you can download the books and maintain the version of the books. So without further ado, let's get started. Question 351 says that a forecast is to be made of the results of 5 cricket matches, each of which can be a win, a draw, or a loss for Indian team. There should be D here for the Indian team. Find the number of different possible forecasts. Also find the number of forecasts containing 0, 1, 2, 3, 4, and 5 others respectively. So forecast can be done in 3 ways. So for 5 matches, total number of forecasts is 3 to the power 5. That is 253. Sorry, 243. Yeah. Following like previous problem, total number of making 0, 1, 2, 3, 4, and 5. Error says 5C0, 2 to the power 0, 5C1, 2 to the power 1, 5C2, 2 to the power 2, and so on. So see, we refer the previous problem. That is why it is important we solve the, you watch the previous videos. So to make 0 errors, okay, we pick 0 matches out of 5 and then 2 to the power 0 because those are the number of ways of making errors. For 5C1, we can pick 1 match in 5C1 ways, and then there are 2 ways to make the error, and so on. Question 352 says that in a club election, the number of contestants is one more than the number of maximum candidates for which a voter can vote. If the total number of ways in which this should be in which a voter can vote be 62, then find the number of candidates. So the solution is the voter has to vote for at least one candidate, and at most n minus 1 candidates. Here n is the number of candidates. For each candidate, the voter has 2 options. This should be also voter. Either vote for the candidate or not vote for the candidate. So number of ways is 2 to the power n. But we have to subtract 2 for 2 cases. 1 when the voter does not vote for any candidate, and 1 when the voter votes for every candidate. The total number of ways is 2 to the power n minus 2 is equal to 62, so n is equal to 6. Question 353 says that every one of the 10 available lamps, this every one could be one word, can be switched on to illuminate certain hall. Find the total number of ways in which the hall can be illuminated. So a lamp can have 2 states, on and off. The total number of states is 2 to the power 10, that is 1024. However, in one of these cases, all lamps will be off. So total number of ways of illuminating the hall is 1024 minus 1, that is 1023. This should be 2. Lots of typing mistakes are there. Question 354 says that in a unique hockey series between India and Pakistan, they decided to play until a team wins 5 matches. Find the number of ways in which the series can be won by India if no match ends in a draw. So India will have to win the last match, so for the series to be over. In the first case, India wins all 5 matches, and there is only one way this can happen. Second case, India loses 1 match and then wins 5. So we exclude the last match to get a total number of matches is 5. Now we can choose to make India win remaining 4 in 5C4. It should be 5C4. That is one way. Similarly, for remaining cases, it would be 6C4, 7C4, and 8C4. Massive typing issue here. So you add this 5C4, 6C4, 7C4, and 8C4, you will get 126 as the answer. Question 355 says that there are n different books and p copies of each in a library. Find the number of ways in which one or more books can be selected. For each book, 0 or more copies can be selected. So there are p plus 1 ways to select each book. So for n books, we have p plus 1 to the power n ways. But in one of these, no book will be selected. So total number of selecting books is p plus 1 to the power n minus 1. Question 356 says that a class has n students. We have to form a team of the students by including at least 2 students and also by excluding at least 2 students. Find the number of ways of forming them. So we have at least n 2 students and at most we have n minus 2 students in the team. The total number of ways of selecting is nc2 plus nc3 plus nc4 up to nc to n minus 2. Now we know that nc0 plus nc1 up to ncn is equal to 2 to the power n. So nc2 plus nc3 and up to ncn minus 2 will end up being 2 to the power n minus 2 and minus 2. This formula comes from binomial theorem. So if you don't know binomial theorem, you please wait and you can skip this problem. Question 351 says that if n plus 1 numbers a1, a2, a3 through an plus 1 be all different and each of them is a prime number, then find the number of different factors other than 1 of a1 to the power n. This should be, well, I think it should be 1. A square, a cube, and so on up to n plus 1. I think there is some problem in this. This should be, we'll see. Okay, there seems to be typing issues in this. I'm not sure what this is. Maybe solution will give us. Number of elements in a2, a3 through n plus 1 is equal to 1. You can choose a1 0 or more times up to m times. So it is definitely a1 to the power n. The number of ways of choosing a1 is n plus 1. We can pick a combination of a1 with all 0 to n numbers, giving us a total of 2 to the power n. Thus, the total number of prime factors is n plus 1 multiplied by 2 to the power n. However, one of these factors is 1. Thus, total number of factors is n plus 1 into 2 to the power n minus 1. So these are a underscore a2, a3. This is not square. This is subscript actually. It is a wrong place. Lots of typing mistakes are there in these questions. Question 358 says that in a polygon, no 3 diagonals are concurrent. If the total number of points of intersection of diagonals intermediate with the polygon be 70, then find the number of diagonals of the polygon. So in a polygon, 4 points make 2 sides and produce 1 point of intersection of 2 diagonals. The number of points is nc4 is equal to 70, that is n is equal to 8. Thus number of diagonals is 8c2 minus 8, that is 20. 8 is subtracted because there is that is the number of sides formed when 2 points are joined. Question 359 says that in a plane there are 2 families of line, y is equal to x plus r and y is equal to minus x plus r, whereas r is in the set of 0, 1, 2, 3, 4. Find the number of square of diagonals of length 2 formed by these lines. So we have plotted the graph of the functions according to coordinate geometry. So this is y is equal to x, x plus 1 and so on, and the other way as well. So if you see the diagram, you see 0.5 plus 0.5 is one side of square, that is the diagonal side. So this is a diagonal, so its side is 1 by root 2. That is the hypotenuse of that. So the diagonal would be 1. However, we want squares with diagonal 2. So we have to combine 4 squares into 1. Number of such squares is 9. So you can compute this. We have computed the square case for the chessboard as well. Question 360 says that find the number of triangles whose vertices are the vertices of an octagon, but none of whose sides happen to come from the sides of the octagon. Total number of triangles formed is 8c3, that is 56. When 2 sides are common with octagon, the number of triangles formed will be 8, as you can find by choosing any 2 adjacent sides of octagon and then shifting them around octagon. When we pick one side with octagon, we cannot choose the third vertex of the triangle with adjacent sides. Thus, we only have 4 points to choose from, and there are 8 sides. The number of such triangles is 8 multiplied by 4, that is 32. Thus, required number of triangles is 56 minus 8 minus 32, that is 16. So with this, we come to the end of 360 problems, 351 to 360. and there were quite a lot of typing mistakes. So now I'll show you how you can download the book. The second link is algebra, third is trigonometry, fourth is trigonometry. You can download the PDF. After downloading the PDF, you should add the date to the file name so that when I update, you know that this is a new version and you can download it. Okay. And again, I will request you to watch the previous videos because a lot of it has been covered in previous videos. For example, how would you complete this square if the number of sides is large or number of lines is large? So you see how this square came to be 9. So you pick 4 squares, it occupies 2 squares along the length. So you shift 1, 2. Okay. So this is 3. That is 1, 2, 3, 4, 5, 5 lines. So n minus 2 will be 3. And this side also 3. So 3, 3 are 9. So that's how we have come to this. So this is essentially n minus 2 whole square. So if you have a large number of n or m, n minus 2 into n minus 2. So that's how you compute the number of squares. That's why it is important that you watch the previous videos carefully. And if you have any questions or you have any feedback for improvement, please make it in the comment box. The problems, the typing mistakes in the book will be slowly fixed. It will take a while because I don't have anybody to help and I'm busy writing the trigonometry book along with other videos, so I don't get much time to fix the problems. So with this, I will end the video here. I thank you for watching the video and I hope that you're finding this series of math videos playlist useful and informative. So I will take my leave here and we'll meet again tomorrow with 10 more problems. Till then, I'll say bye to you and you should keep practicing. Thank you for watching the video again. Have a nice day.